Hello guys, my name is Matheus Schneider and this is my SVS-8 submission for the Superteam Brazil, the Solana Vault Standard bounty, and this is my SVS-8 multi-asset basket vault, a single entry program that holds up to 8 SPL tokens with Oracle priced shares and proportional deposit and redeems. This is my commit history. They went through the full security review, 2 rounds with Completeness, all P0, P1 and P2 findings addressed across both rounds. So this is the last 5. It's the 44 the pull merge history in the GitHub. So let's do some tests right now. We're gonna enter test with the SVS-8. Testing this will filter only the SVS-8 tests, and while it runs it takes a while. I'm gonna explain what we are testing. So the first 15 tests cover the full life cycle of the SVS-8. They create the vault, they add 2 assets with 50-50 weight allocation, they set the Oracle prices, minting tokens to the user, deposit a single asset, and deposit proportionally across both assets atomically, redeeming proportionally and redeeming a single asset. And we also test the circuit breaker, the pause and unpause. So it takes a while, like 1 to 2 minutes, but let's wait. Okay, here it goes. So these last for our security regression test that I added after the review rounds. So let's walk through each one. The first is the reject update Oracle twice to validate the P03 fix. Oracle's accounts now use it init if needed instead of init. Before the fix current update, Oracle second time would fail because the account already existed. Now it correctly updates the price. Second, you put the rejects reading proportional with wrong vault TA. This is the cross asset drain attempt. We pass asset B vault token account in an asset A position. The program catches it but requires the vault TA key equals the asset entry asset vault and returns asset not found. The third is the reject deposit proportionals with subset of assets. We pass only one asset in a 2-asset vault. The completeness check the remaining accounts land must equal number assets of times 5. This catches immediately. And the fourth, the reject deposit proportional with wrong mind. Pass mind B in assets A quintuplet position. The mind key checks against asset entry asset mind catches the before any CPA happens. So this is it. 19 of 19 passing with 0 failures. So let's do a code walkthrough on the deposit proportional. Okay, let's do it right here. As you can see on the line 84, the recall vault TAI key equals the asset entry asset vault. This is critical P0 finding around the round 1. Without this check, an attacker could pass their own token accounts on the vault TA. The transfer would go nowhere useful, but shares would be calculated against a 0 balance. So giving the attacker billions of shares to drain the vault. The line 42 is the split asset len. So what it does, the P12 fix on round 2, instead of requiring remaining accounts to be exactly number of assets times 5, we split the boundary. Everything before the split in asset counts, everything can do to model PDAs, fee configs, cap configs, locks and configs. This makes all the 6 models compatible without breaking the layout checks. Okay, the redeem proportional. as you can see. The token program key comes from the mine owner inside the loop asset. There was to be 02 to round 2. The previous version had a single global token program key declared before the loop, which would fail in the mixed baskets. Weird, some assets are SPL token, and the others are the 2022 token. Now, which one asset uses their own correct program? And the vault TI key equals the asset entry asset vault. It was the P11. The deposit proportion had this check, but the redeem proportion was missing it, which would across a drain substituting to a vault accounts. And let's do a vault.net test right now. So I'm gonna run this script. Okay, and the running is the real program is deployed at some this ID at the Solana DevNet. So step 1 is gonna create 2 mock tokens, an USDC and a USDT. Okay, fresh pairs. Step 2, the mine tokens, 10 for each one of the wallet. At step 3, we are deriving all PDAs. So the vault PDA is doing right now. Sharing. And step 4 is initialing the vault. If I click this link, I'm going to open the Explorer. As you can see. On step 5, adding assets. 6, setting up the Oracle prices. And the deposit sequence at step 7. So to redeem, in the step 8, the redeem proportional. We burn 50-50. The shares in receiving the proportional amounts of the pooled assets. So the links are here. And the redeem confirmed. All steps completed successfully. I'm gonna show in the SDK script right here. The basket vault class full type methods for every instruction. PDA helpers exported for the vault address, shares mined, asset entry, the Oracle price scale, and constant match on the chain value. Everything typed and no any types. The CLI command, the basket init, info, assets at price, deposit, redeem, pause, transfer authority, all accessible via Solana, the vault basket command. I'm gonna run some first tests now. Show it to you. Well, not right. They are covering the math invariants. The weight sum never exceeds 10,000 BPS. The share math is monotonic. The more deposit always mean more shares. So the portfolio value computation never overflows silently. The Oracle's stillness detection always blocks the stale prices. So this run never properly based fuzzing against the basket math. So that is it. This is my first time trying to run some commands and type in Rust to aggregate the Solana project basically in Brazil. And what it does, basically I showed to you, is the SVS-8, a full wake-up program with 19 tests, including 4 security regression tests, the SDK, SLI, the fuzz tests, and 2 complete security reviews addressed. If you are curious, the RTPR number 44 at the GitHub in the Solana Vault Standard. So that is it. Thanks for watching.